Hello grade 7 learners, welcome to the new set of school years that you have, and we're now on the first module in the first quarter that talks about sets. But before that, we're going to give credits to those people who have knowledge and capacity and power of minds to help us out to initiate to make this module. Our writer, our editors, reviewer, template developer, and the management team on our Department of Education, Region 11, as well as the Division of Diversity. Okay, so our main focus in this discussion is of the module that we have in particular in the sets is we have to illustrate. We're going to illustrate further about well-defined sets, subsets, universal sets, null sets, cardinality of sets, union and intersection of sets, and the difference of two sets. Then we are going to solve problems involving sets with the use of Venn diagram. So we have these two sets of objectives that we have in order for us to work or to understand and to discuss this topic that talks about set. But as we deal with the sets, let us try ourselves on how we have inculcated your knowledge about what the set is all about. Then we have here a certain questions. Choose the letter that best answers the question. Write your answer on the space provided before each number. In the number one question we have here, what do you call a collection of well-defined objects? Is it A, set, B, universal set, C, which is null set, and D, which is subset? So the answer for this is letter A. Okay, for number 2 is we have here, which among the follow set is written in the roster method? A, set A is the set containing the elements 1, 2, 3, 4, 5. B, A is equal to the set of all x such that x belongs to natural numbers wherein x is between 0 and 6, or just we say x is greater than 0 but less than 6. C is set A is equal to the set 1, 2, 3, 4, 5. Then D, both A and C. So in this case we have here an answer of letter C. So in number 3 we have, what do you call a set that does not contain any element? So we have here A, set, B, universal set, C, null set, D, subset. So still the same, the answer is C. What is the cardinality of set G if set G is equal to the set A, B, C, D, E? So we have here A, which is 6, B is 4, C is 6, D is 5. So the answer of this is D. Next is we have here how many subsets of, so there, by the way, in number 4 we have double value here, so this one must be 10, or just we say 8 rather. So how many subsets do set D has if set D is equal to 1, 2, 3, set 1, 2, 3, 1, 2, 3. So A is 3, B is 6, C is 8, D is 10. So the answer of this is C. Okay, so as we done through with the let us try, so let us now focus on the main concern in this discussion or in this topic. So as you identify, as you observe, a set is a collection of well-defined objects. So, meaning to say, when we talk about sets, it means that we are going to group together. So, like for example, your section. So, section, let's say, section A, section Mahogany, section Rizal, section Azucena, section Waling-Waling. So, that one is grouped together. That one are grouped together according to its section. That one is considered now as a set, and those students or learning belong to that section was what you call it, elements or the objects. Objects is, it doesn't mean that we are talking about certain things. It's also considered non-living or living things, as long as that one belongs to that group, and that one is what you call it, elements of the given set. Like for instance, we have here set of countries in Southeast Asia. So Southeast Asia falls where in the continent of Asia, wherein Southeast Asia is the falls and below to the China. So the countries that compose of Southeast Asia are those countries like Brunei, Cambodia, East Timor, Indonesia, Laos, Malaysia, Myanmar, Philippines, Singapore, Vietnam, and Thailand. So, meaning to say, when we talk about set of countries in Southeast Asia, so meaning it considers now as grouped together, so it is well-defined set, since we can differentiate Southeast Asian countries from the other countries like Middle East, or like say Central Asia, European countries in the Europe. So that one is not is different from the what you call Southeast Asia. So those countries that I have been mentioned are those countries belong to the Southeast Asia. Then that country stands for the elements of that set of that Southeast Asia, set of countries in the Southeast Asia. Okay, we also have a set of five Philippine presidents. So we have here first five. So the first one that we have is our former President Emilio Aguinaldo, Manuel Luis Quezon, Jose P. Laurel, Sergio Osmeña Sr., and Manuel Rojas. So these five former presidents are what you call it element on the given set of first five Philippine presidents. Then we also have a set of students in your class. So since we don't know yet your behavior of your classmate, so it was not well defined. So what would be the characteristic and how to identify the student? So therefore it is not well defined set, since there is no specific criteria or common agreement so to claim as that one is an honest student, so as to what it meant by honest people. So therefore this one is still considered a set, but that but we don't know it yet if there is some certain elements belong to that set. Okay, so let's try to give an example of a certain number. Set of natural numbers. Okay, when we talk about set of natural numbers, numbers that are counting numbers. So we have here 1, 2, 3, 4, 5, and so on. So we have here a roster 1. This one here, the braces, is what you call it Brewster method that we have. Okay, so set of whole numbers. When we talk about set of whole numbers, are those counting numbers and including the 0, 1. So represented by set big letter W. And take note that when we able to write a certain set, it must be written in the upper script or capital letter in the English alphabet. So based on the given that we have here, as I've been mentioned, so here we have capital letter G that is defined as set A, B, C, D. So if you encounter a capital letter, that one is in this kind of discussion or topic, that one is considered set, a well-defined certain object. So another one is set of integers. Somehow, by the way, some other book in mathematics, this one is, if you encounter the symbol, that one is a natural number. Another one for a whole number is this one, still the same with W, but then there is a double script in the part. We have also here Z. So when we talk about Z, or the integers, are those sets are the whole numbers as the negative numbers. Okay, so we are now talking with the infinite set and finite set. When we talk about infinite set, are those elements having an ellipsis, the representation, meaning to say, when we encountered ellipsis there, the 3 dots or the ellipsis or the 3 dot, again the 3 dots there, so we have ellipsis, so that's the spelling. So meaning to say that these are the example of what you call it, infinite sets. Now, whereas when we talk about finite set, are those sets wherein we have the number of elements can be counted. So finite, the difference now of the finite set to the infinite set are those counted sets. So let's say set A composed of a set, composed of an element 1, 2, 3, 4, 5. Since this set A having a 5 set of elements, so therefore this one is considered as one of the examples of finite set. Okay, how do we able to read this? So set A is equal to set 1, 2, 3, 4, 5. Now we also have a symbol referring to this. That one, how to write that one is we have here, that one there. So this one is the epsilon, one of the Greek alphabets, one of the Greek letters that we have. This one this symbol is represent an element. So therefore 4 is an element of 1, 2, 3, 4, 5. So given this one, since we could find 4 here, so therefore we could say that 4 is an element of 1, 2, 3, 4, 5. We also have an epsilon, but then it is just slash. We just slash the epsilon. So meaning to say, this one is not an element. That one is not an element to read. So here, if this one is an element, that one there. Okay, by the way, that's that one. So since we could not find 7 in this given set, we could say that 7 is not an element of the set 1, 2, 3, 4, 5. So written as 7 is 7 is not an element of a set 1, 2, 3, 4, and 5. So that's it. Okay, we also have set notations. Okay, take note that when we talk about set notation, it is represented by the brace. And then if we are going to understand that the big letter or the capital letter or uppercase letter in an English alphabet, that one is serves as set. Is the representation for the set. While if we have encountered small letter in a Greek alphabet, that one serves as element. Okay, this one, two braces, is representation of the symbol of the set. So here we have, this one reads as A is a set of 1, 2, 3, 4, 5. B is equal to the set E, F, G. C is equal to the set L, M, N, X, Y. So these are the ways in how to read everything. Okay, we also have verbal description. Okay, when we say verbal description, it's just a statement that can be changed into mathematical description or mathematical statement. Okay, given this, set A is a set of natural numbers less than 7. So A. Okay, take note that when we talk about set of natural numbers, it is a infinite sets, because when we talk about natural numbers, are those elements composed of 1, 2, 3, 4, 5, 6, 7, 8, and so on. While here is just a specifically stated here that set A is a set of natural numbers less than 7. So what are those numbers less than 7? So 1, 2, 3, 4, 5, 6. So therefore, set A is the set of natural numbers less than 7. So we have 1, 2, 3, 4, 5, 6. So that's it. That is how we cater with the answer from the verbal description going to the mathematical statement or mathematical symbol or mathematical description. We also have set B. So set B is equal to the set of integers between 1 and 10. So we are between 1 and 10, so we will not be able to include the 1 and the 10. So we start to the set 2, 3, 4, 5, 6, 7, 8, 9. Okay, we also have set C. So set C, we have B, E, H, O, R, T. Okay, take note that as you can see with my answer, with the answer here, everything is written as from lowest to highest. So in order. I just not use the reshuffled one or the shuffled one, because accordingly, for us to be able to have no problem at all in identifying the elements of the given set, all we have to do is just to arrange everything. Maybe we could get a problem as we encounter the missing one for the given state or the given element. So that is why we're going to write it in the order of either highest to lowest or lowest to the highest. But here, I just write everything here into lowest from the smaller valued number to the upper value. Then if every letter from the order of the English alphabet, so I just write this kind of way. So in number 4, we have here set D is a set of natural numbers greater than 8. So greater than 8, so 9, 10, 11, 12, and so on. So we have here 3 ellipses to represent something. For the next part, since it is just the D represent the D now here is modified or just defined as the set of natural numbers greater than 8. Okay. Then we proceed also to what you call it roster method or listing method. So with the use of the braces is what you call, and inside of it are those elements, and that one is what you call it a roster method. So as we go through previously, that one there explaining that I just explaining everything there. So the set builder notation or rule method is another way in writing the certain set, wherein to get this one is we have here given set, capital letter, we have the capital letter 1, so the set of A set A is equal to the set of all x such that x has property of the give property P. So we have here x, meaning to say those unknown, those identified x, and those elements is represented by a certain variable. Then to separate this to its, what does it define as in that given example for the verbal description of the given set. So we just have here this kind of symbol that and it says such that. So we have here x has a property P. So set builder notation or rule method, that one is what do we have there for the given. So looking back to the example that we have, set A. So how to write this one in the given set builder notation. So we have here set A is the set of all elements represented by x such that set of natural numbers. So our elements represented by x is belong to the natural number. So that one there, such wherein less than 7. So x is less than 7, or somehow the set of all x such that x is an element of natural number defined as 1, 2, 3, 4, 5, 6, because it is just less than 7. Okay, for letter B, set B, okay, another way, this one here, I will put it here. Set B is the set of all x such that set of integers. So our element belong to set integer, wherein the x that we have is between, when the symbol for between is greater than 0, x is greater than 0. Okay, I will be able to erase because not good to look at with. Okay, just read. So we have here the set x is greater than 0 but less than 10. That one there, that one. Okay, then the other one around is set of letters. So let's check first how to write everything. Okay, so that's it. So there's so many ways on how to write everything. So from let number 3 here, we have C is the set of letters. Okay, so we have here, I'll be able to compare everything here. So because the book that we have used the Z there. Okay, wait. Okay, Z for any elements. Z is the letter and the word from the word brother. That's it. Then set for number 4, we have set D is the set of natural numbers. Set of natural numbers. So X element of natural numbers greater than 8. So greater than 8. That's it. So that's it. That is how we write everything that we have. Okay. So you can also use any letter in the English alphabet, provided that one is a small letter 1 for the representation of the elements, as I said. Okay, let's proceed to null set. When we talk about null set, there are some set does not contain any elements, so these are called null set. Okay, in the symbol we have here that one and this one. The set of negative numbers, the set of negative natural numbers. So we could not, since we talk about natural numbers, and take note that there is no natural numbers we have no numbers that are negative natural numbers. So we have here that ones. Empty set. This one is the empty set. So we just only write the braces just to include further. Okay, that one or this one. Set of months in a year with 33 days. There is no such 33 days in the calendar in the month in every month. For a month that we can glance from the year that we have. So still the same with the null set or empty set. And take note, you're just also, if you just write this one so this is empty, so there's no such element here. So if you just write also the null set, and the set of the null set is not the same with this. So careful in writing that one. Okay, because if the symbol if this symbol inside the braces, that one there now, it means that there is some element on that set. But if you say something, that one is, if you consider that one as null set, that one so meaning to say that one is not anymore a null set. So careful, either of these two will do. For for identifying the empty set. Okay? We also have the universal set and subset. Okay, but before that, we're going to understand what does it mean by the Venn diagram. When we talk about a Venn diagram, is the rectangular plane this one here, rectangular shape. The rectangular shape stands for the plane that we have. Then after which is we have our circles, two circles with the given numbers. So meaning to say, since it was grouped, this circle here was this group here, this circle here has an element 157, and this one here has an element of 62. So meaning to say, we have two sets from the mother set, which is represented by the Venn diagram, the rectangular one, and another one is it was clustered, it was grouped there. So meaning to say, that one is considered now as there is some set inside of the mother set. That one is what you call it subset. Universal set is another name for universal set, is what you call it mother set. As you can see in the Venn diagram, the mother set, the whole. So then the 3 and the 4 there does not belong to the two given circles, so does not belong to that given set, but belong to the mother set or the universal set. That is how we analyze further on the certain figure in the Venn diagram. So meaning to say that the Venn diagram illustrates something, how to figure out the certain numbers or the certain identifiers for us to work to analyze that how to picture out, to visualize everything for the given example or for the given set. Okay, so we have here, okay, universal set, the rectangular shape one, and then this first circle here specified already. So in this figure, it was named set A, then the other one is set B. So if we're going to analyze therefore the situation or the Venn diagram that we have, set U has an element of those all elements that can be found on the big rectangle. So all those numbers 1, 2, 3, 4, 5, 6, 7. So set A, we have set 157 because it was grouped here. Set B is 26. Set 26. So all elements. So here. So let's proceed to the next example that we have that deals with the universal set. Then again, when we universal set deals with what we call this U, or some other books. You can go over the other set on the English alphabet, but as far as we know, when you talk about universal set, all the numbers we found in the Venn diagram or in the rectangular shape, even if we have sort of circles there inside of it. So take note with that. And by the way, we have here a correction for this. This one is not 13, but this one must be 15. Okay, so let's proceed. So in this given example of the Venn diagram that we have, we're in the set B that we have having another set of A inside of it. So what does it mean? It means that all the elements in set A is also an element in set B. Then both set A and B are belong to the universal set or the matter set. So in this case, we can go with a given. So set A that we have having a set of 13, then 16 as its element. B we have equal to set 30 to 11, 13, 16, 17. And our universal set in this given is equal to set 11, 12, 13, 14, what else? 15, 16, 17. Okay, so we have that. Now, again, if you're going to analyze carefully the set Venn diagram because of its pictorial representation in dealing with numbers in mathematics. So let us check. Set A shows elements 16 having an element of 13 and 16, while set B also having an element of 11, 13, 16, 17. Universal set is we have 11, 12, 13, 14, 15, 16, 17. And take note that the 12, 15, and 14 is outside the big circle, which is in the set B and set A. So that is how we represent the certain pictorial graph of the given set, and that is what you call the Venn diagram. So we have that. Okay, so now let's proceed in such a way. In this given, we also have the word subset. When we talk about subset, it is a set. It is a set considered to be a subset of another set if all the elements of a certain set given like set A we also found in set B. So in this example, in this given example that we have, this one here are 13 and 16 be found in B? Okay, yes. All the elements in A here in this given are all found in set B. So therefore set A is a proper subset of set B. Is another, I also get a question. Is all elements in B be found in set B, set A? Again, are all elements in B, which is 11, 13, 16, 17 be found in B, in A rather? So no. So therefore B is not a subset of A. So take it with that, because accordingly when we talk about subset, if all elements of a certain set represented by A are elements of B, so it is not vice versa here in this given, because the 16 and 17 are not found in set B, in set A. Again, 16 and 17 are not found in A. So therefore we could say that this one, that set B is not a subset of A, but set A is a subset of set B, because all the elements of A, okay, I erratum for a while. It's not 16 and 17, but rather, I'll erase this one for a while. This one must be 11 and 17 for set B, that we have 11 and 17 as the elements of set B are not found in set A. So that is why B is not a subset of A, but A is a subset of B. Okay, that's for clarification. So we now have, so this symbol here, this one symbol, the subset symbol, this one reads as set A is a subset of set B. That's it. Okay, for more information, or for everything that we should do, is we have here some sort of example. Okay, so we have here an example that we have. So as you can see, determine all the subsets of set A with the elements of A and AB. So set AB, A is a subset of by itself. Take note with that, because this element is also found in set A, so that is why A is a subset of A. Empty set is a subset of every set. So in this case, we have here null set or empty set is a subset of A, because accordingly, based from the definition, every empty set is just also a subset of every set. So since in a given is set A, so therefore empty set is just a subset of A. Each element is a subset of a given set. So we have here, we have to break this one out. So we have here set A, set B. So therefore this two here, set A is a subset of set small letter A is a subset of big A, then set B is just a subset of A also. So we have that. So therefore in this case, when we have identifying how many subsets do we have in this example, so we have here 1, 2, 3, and 4. Okay, another one is determine all the subsets of B. So the first thing is this one is a subset of a given set, which is set B. Empty set is also a subset of set B. This one here, this one, these elements, these sets. So in other words, this set 1, set 2, set 3 are also a subset of set B. And we have here set 1, 2, set 1, 3, set 2, 3. The combination of the elements by 2 is also a subset of set B. So therefore, if we're going to identify further how many subsets do we have in this given set B, is we have here 8, because so as we able to count all the subsets that we have. So we have here 1, 2, 3, 4, 5, 6, 7, and 8. So for us to determine the value of the number of subsets given by the two sets, is we have given by the set rather, is we have the formula 2 to the n, where n are the number of elements that can be found in the given set. So n is number of elements, n here is a number of elements that we have. Okay, so let's say how many elements here in a set A. Set A is composed of elements A, B. So we have two sets of elements of 2 to the square, and that is 2 times 2. We have here 4. So in other words, so that is why we come up with 4 sets of elements. There are 4 sets of subsets that we have in the given set A. we have here 1, 2, 3 given elements of the set B is we have 3 sets of elements of 2 to the 3 is 2 times 2 times 2, and we have here 8, 2 times 2, 4 times 2, 8. Okay, you have that. So as I said, this one is the formula given. And if we talk about cardinality of sets, is the number of elements in a finite set. So number of elements of the finite set. So we have here, this is in a finite set that we have. So we have here, if we're going to identify the cardinality of the set A, so we have here 1, 2, 3, 4, 5. So we have here 5 cardinality that we have in this given set A, in this example. So we just only count the elements. So if we're going to count the elements here in the set B for this example, we have here 1, 2, 3, 4, 5, 6, 7. So the cardinality of this is, the cardinality of B, of the set B is 7. How many subsets do we have? How many subsets do the set C have? So what do you think? So when you see how many subsets, so again we're going to make use of the formula 2 to the n of A, or 2 to the n, where n is the number of elements. So we have here 1, 2, 3, 4, 5, 6. So we have 2 to the 6. So as you can see here, 2 to the 6 is 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. So in this case, this is not anymore 32, but this one must be 64, another set of typographical error. Okay, because accordingly we have 1, 2, 3, 4, 5, 6 as the number of elements that we have. So we have 64. So this must be 64. Okay, how many subsets do the set D have? 1, 2, 3, 4, 5, 6, 7, 8. So you have here 8. So 1, 2, 3, 4, 5, 6. So this is now 64. 128. 1, 2, 3. So 128 to 56, and we now have 1, 2, 3, 4, 5, 6. So here 64 times 2 is 128 to 56. Okay, that is correct. So the number of subsets that we have in this given set D is 256. And we also have a union of sets. When we talk about union of sets, so we get given by the union of two sets A and B is the set which consists of all elements that belong either A or to B, to A or to B. So in this case, we're going to shade the two given sets that we have. So we're going to collect all the elements be found in set A and B, so that we could claim that one as our union of the two sets, and it is represented by A U B. So A union B. Like for example, we have here given universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the sets containing A is set 1, 2, 3, 4, while the B is set 1, 6, 7, 8. What is A union B? So we're going to associate all elements that can be found in both sets. So since we have here 1, 2, 3, 4 for set 1, 2, 3, 4 for A, and 6, 7, 8 for B, so therefore if we're going to unite everything, A union B is equal to the set of 1, 2, 3, 4, 6, 7, 8. And when we talk about this joint set or mutually exclusive set, are those given two sets that cannot be met, or there's no such common elements that can be found in the two given sets. Again, there's no common elements that can be found in the two given sets. So if two sets do not have any common elements, so that is why, as you can see in this given Venn diagram, we don't have any common elements. So therefore this one, A and B are disjoint sets. Okay, now we have here given the universal set 1 2 3 4 5 6 7 8 9 10, and the sets 1 2 3 4 5. Set D is 2 4 6 8. What is A? C union D. C union D is, we have 1 2. Again, if they have common, it is understood that it is just equivalent to 1. So 1 2, and then as I said previously, you're going to arrange from lowest to highest so that we could be able to identify or easily get the given set if you're going to arrange it that one. So 3, the 4, the 5, the 6, the 8. So as I said, since 2 and 4 are those elements that can be found also in both two sets, namely C and D. So we could just have to write that one as 1. Okay, we also have a Venn diagram. So this is now the Venn diagram of the given that we have. So the intersection, the common elements are 2 and 4. Then we have 1 3 5 for the C, then 6 8 for D, and the other part which cannot be found in both sets, small sets, the 7 9 and the 10. So the colored region stands for the given two sets, or just the union of the two sets. So in this given Venn diagram, we have here, let's write this one first. The given, the universal set that we have is equal to the set of 1 2 3 4 5 6 7 8 9 10. Okay, we have also the given set C is we have 1 2 3 4 and 5. Set D is equal to 2 4 6 8. So that's how we catered here in the Venn diagram that we have. Now, in this given, when we talk about the intersection of two sets are given this. So if intersection of two sets given A and B is the set of all elements common to both A and B. So the word common here are highlighted. The word common here rather is highlighted for the given. So as you can see here, and it is denoted by the way, this symbol here, the intersection of two given sets, A intersection B. So this is the symbol that we have. So from the given that we in this part, in this given Venn diagram, the 2 and the 4 is the intersection set, intersection value of both sets, because 2 here and 4 can be found in set D and set C. So as we go with the example, so in in the previous Venn diagram. So this is the given. So perform the given set of operations, sketch its Venn diagram. So in this Venn diagram, so in this given, they don't have any common. So this is what do you call it, disjoint set. This is what you call as disjoint set. So as it mentions previously, so this is the disjoint sets, a disjoint sets, no common. So the answer is empty set. So as you can see in the Venn diagram given, so we have universal set. Set A is having a value of set elements 1, 2, 3, 4, while set B we have 6, 7, 8. And then the other one, those elements which are not found in both A and B, set A and B, are those elements 5, 9, and 10. So this is just empty set or null set. Okay, another example given is we have given a universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, by the way, before we go further with the Venn diagram, so let us try to work it out how to make a Venn diagram given this kind of set. So we have here universal set, okay, represented by set U, and then we have to going to compare. So we have here D, C, and D. So the first thing that we should do here is that we're going to get the work for the common, so that there is the circle. If we make use of the list here or circle, there is an intersection of those two circles that we have, then another 4. So that is why the intersection is 2, 4. So in this case, so we now have to make use of this. We have here C. We have to make use of this. So we have here C. We have here D. So this is set C, and this is set D. So for set, so this is now they have common. So they have here 2, 4. We have to start with a common in writing the Venn diagram. So since we already written the 2 and 4, so this is now, since this is C, so this circle here is C, so we have now 1, 3, then 5. The other one is for set D. We have here again we already write the 2 and 4, so we have here 6 and 8. So you know the universal set that we have, so we already have 1, 2, 3, 4, 5, 6, 8. So the 7, the 9, and the 10 we found outside. 7, 9, then 10 outside the two circles, which is outside the two circles but inside in the rectangular shape that we have. So this is still the same as you can see here in the Venn diagram posted in our book. So therefore in our module, so this is how we write a Venn diagram. Okay, we also have a definition which is stated as difference of sets. When we talk about difference of two given sets, the difference of set B from set A is the set of all elements in A that are not found in B, which is denoted by which is denoted or written in the symbol A minus B. So in the pictorial graph or the Venn diagram, this is only found in outside the intersection, but in the circle A or circle A. So this is now the symbol, then A minus B, or the difference of two sets. The difference of set B from set A is this one. So in this given example number 1, we have here universal set. So example number 1, we have to draw, and we are going to compare further. Okay, wait. So we have here infinity. Okay, so if we're going to check further for this, is we have take note that in set A, if we're going to compare A and B, they don't have any common. So meaning to say, they don't have any common, these are the disjoint set. Okay, no common at all. So we have here 1, 2, 3, 4, while B is 6, 7, then 8. Then what is left here is the 5, 9, 10. So we have here 5, 9, then the 10 outside the two given, but all just found in universal set. Okay, A minus B. So are all elements in B, when we talk about difference of two given set, is all elements in B that are not in B. So therefore, in this case, we have 1, 2, 3, 4. How about is it possible, like when we have U minus B, what are the sets given? Okay, all elements in U, set U, or the mother set, or the universal set, not found in B, not in B. Is it correct? That are not in B. So B. So therefore, we have given, like for instance, so those elements in set B. What are those elements in set B? So the elements are 6, 7, then 8. So therefore, if we have U minus B in the given set, the answer for this is set 1, 2, 3, 4 is 4, 5, 6. No, that there's no 6 here, by the way, because 6 can be found in set B. Then we proceed to 9, 10. Okay, let's check. 1, 2, 3, 4, 5, 9, 10. Okay, that's correct. So that is how we catered with this answer. Okay, so the shaded portion for this should be here. If we have, so this is the shaded portion. not not this one. This is not the shaded portion. This must be here, the shaded portion here, because the answer is 1, 2, 3, 4. Okay. Next is we have B minus A. B minus A is we have, okay, considering this one, B minus A. So since it is disjoint, so the answer is 6, 7, and 8. So the shaded is this one, not this one. Okay, because B in, okay, that's it. Okay, by the way, I have another follow-up question. What is the answer when we have U minus A? Okay, U minus A we have. Okay, now let us try to look at the given set 1, set A. So this not, we have to eliminate this 4 elements so that we could identify now the U minus A, the difference of set A, U and A. So the answer now would be 5, 6, 7, 8, 9, and 10. I just only copied here because those elements that are not highlighted one. Okay. Next is we have another set of example, C minus D. So what is C minus D given this universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 with a given set C 1, 2, 3, 4, 5 and D 2, 4, 2, 4, 6, 8. So we have C minus D. We have highlighted. I have to highlight this, a common. They're common. Since C minus D, the minuend is C, well, the subtrahend is D, so we only cater the answer 1, 3, 5. That's it. This is now the shaded part. That's correct. That's the correct one. Next, okay. I hope you understand this kind of explanation and how to deal with the difference of two given sets. Okay, now let's proceed to the what you call it complement of sets. So when we talk about complement of a set, we have here the definition. The complement of set A is the set of all elements in the universal set which are not element of A. So we are now on the complement of sets. When we talk about complement of the given sets, is defined as the complement of set A is the set of all elements in the universal set that are found that are not elements of set A. So noticing that we have here a given Venn diagram. So considering this one is our universal set, and this is our set A. So this is our complement of a set, the outside part of the set A, because again, as it says, they're not elements of A, so these are not an element of A or A to the A complement. As you can see, the shaded portion or the color blue one. So if this would be our set A inside the circle, so outside of the circle will be our A complement. So it is represented by this symbol. So or other book that we have is also written as A prime. So meaning to say that one also serves as A complement or complement of a given set A. So for example, we have here a given universal set 1, 2, 3, 4, 5, 6, 7 as its element, and we have here set A. as set A given as 3, 4, 5. So what is A complement? So the A complement here, since our given is 3, 4, 5. So we have here 3, 4, and 5. So the A complement is those elements not in the shaded part. So we have here 1, 2, 6, 7. So this is now the A complement given. So when we draw about in the Venn diagram, so we have here circle A, first this A. So we have here 3, 4, 5, 3, 4, 5. Then 1, 2, 6, 7 outside. So this is now our A complement, the shaded blue one. Okay, that one. Okay, another set of example. We have here give the universal set given by 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The set C is given by we set 1, 2, 3, 4, 5. Set D is given by the let's say set 2, 4, 6, 8. What is the complement of C? Set C complement. So then again we have here 1, 2, 3, 4, 5. This element that can be found in the universal set, but also found in the complement of a set. So the opposite of that is 6, 7, 8, 9, 10. So this is not a complement of a set C. Okay, that's how we cater with the given. How about if we have complement of set D? Let's say we have here D complement. So in this case, we'll be dealing with the complement of set D. So we have here 2, 4, 6, 8. We have here 2, 4, 6, 8. These are the elements that can be found in the set D. So the shaded part, the yellow shaded part that can be found in our set, the universal set. So therefore, those that are not shaded, highlighted rather, are those elements for complement of set D. So we have here 1, 3, 5, 7, 9, and 10. So that's it. Okay. How about if we have let's say C union D. Okay, let's recap what we have learned. So C union D are those elements that can be found both set C and set D. So set C is we have 1, 2, 3, 4, 5, 6, 8. So that is the complement the union of C and D, or C union D. So how about if we have C union D complement? So means since we have a value of the union of C and D, the union of C and D, so therefore its complement is we have now. So this is now the elements given by the union of C and D. So we are going to highlight everything. 1, 2, 3, 4, 5, 6, 8. So the complement of C union D is what? We have, yes, that's correct. We have 7, 9, and n. Okay, so I hope you have shared you have enlightened your mind with regards to what we call about the complement. Okay, so I will leave this, let us practice with you guys, because this is your activity, and I just want to, for you to, I just hoping that you're going to practice yourself dealing with those, dealing with the given sets that we have, and I will be able to share this for the future videos. So don't forget to subscribe, follow, like my video, my channel, for you to be able to notify for the future lesson. Then and then same as with let us practice. Then let us remember. Okay, in the let us remember, so this is now the summary that we have. So a set is a collection of well-defined objects. Then the elements are those be found in a given set. Inside the roster method, the verbal description method is a way wherein we're going to state a sentence form of a given set. The roster or list method is represented by these two braces, are representation for the given set. Then set builder or rule method is a way for in writing certain rules determining the elements of given set stated. And you also and Venn diagram is the pictorial representation or illustration that used to show its relationships, similarities, and differences among the things or group of things. Or in short, Venn diagram is the pictorial representation in such a way we have to visualize further from the verbal going to pictorial visualization. Universal set, which is denoted by this symbol, contains, this is wherein a set that contains all elements under the consideration. Okay, subset is considered as given set with all elements. Subset of a given set is a set if all elements of set A are elements of set B. The cardinality of the given set is a number of elements in a finite set. So given as n of A. The union of the two sets is the set of elements which can be found or belong to either A or B. Then, if all the set of elements are common elements, then this one is what we call the intersection of two given set. The difference of the set from A minus B, or is a set of elements that are not in a set of elements in A that are not in B. Then we have complement of a set is a set of elements that are not elements of A. So I will leave this let us assess with you guys for you to enhance again, and I will be doing this video, another set of video for you to be able to compare your work as in mine, and then let us try to understand or if your work is correct or not. I will advise you just to share, like, and even subscribe my video work for your future reference. Okay, so goodbye for now, and the last page that we have is the answer given by our module. So hope you enjoy it. Goodbye.